Hey guys, how's it going? Back with day 25 here. I want to take a look at doing some of these problems using a calculator. So what I have here is a problem, parts A and B from the 2016 AP Calculus AB free response test. So let's take a look at it. I'll kind of read the prompt for you here. For t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals 1 plus 2 sine of t squared over 2. The particle is at position x equals 2 at t equals 4. So what they gave you here is when you read this, you have to understand the equation given here is a velocity equation, right? We should know that from v of t, but it also says it's a velocity equation, okay? They also give you a position at a specific time. That's going to be more helpful later on when we're doing this. For right now, we should be able to answer both of these questions just with that v of t equation. Okay, so when we read these problems, we need to understand our definitions and our concepts here so we can know what to do. The first question, part A here, says, at time t equals 4, is the particle speeding up or slowing down? Okay, so we have a calculator available, but we need to look at this question and know immediately what we need to do. Speeding up or slowing down, right? Speed increasing or speed decreasing. We need to check both the velocity and the acceleration at t equals 4. So right away, I need to figure out v of 4 and a of 4. And what I'm looking for here specifically are the signs of these. So I need to know the sign of velocity at time t equals 4, and I need to know the sign of acceleration at t equals 4. Right? If the signs are the same, then the object is speeding up. If the signs are different, then it's slowing down. Now, how we accomplish that is going to be a little bit different here because we have a calculator. Okay? I don't have to plug this in by hand. Right? I'm going to let the calculator do the work. So I'm going to show you kind of how that works. So here's the first thing that we're going to do. Okay? We're going to go to our graphing calculators. So if you don't have yours with you, just follow along. If you do have it with you, get it out and try this with me. So let's go to our calculator. And we're going to go and type in this equation. Now the equation was 1 plus 2 sine, for the alpha y equals for the fraction bar, t squared over 2. Okay, now even though the equation says t, our calculator, we're just going to use in terms of x. I just want to take 1 second here to double check to make sure I type this in correctly. If you type this into your calculator graph incorrectly, it can cause all kinds of problems, right? You could potentially get every single problem wrong because you just typed it in wrong. So it's worth double checking. So let's take a look. 1 plus 2 sine of t squared over 2. And I got 1 plus 2 sine of x squared over 2. Okay. The second thing you need to make sure of on your calculator is that your calculator is in radians. We need to be in radians for this entire year. As you can see, my calculator up here says radian. If you have one of the black and white ones, hit the mode button and just ensure that radian is highlighted. Okay. Okay, the second thing I want to do is I like to, before I hit graph, some of the things we have to graph are kind of complicated functions and take a while to graph. I want to set my window first. Now what they told me is t is greater than 0. Well, t is acting like x in this, so I'm going to let my x min be 0. And my x max, they didn't give me a range. If they did, I'd put that range in. My x max, I just need to make big enough so it has 4 in there. So maybe I'll do like 6. Okay. So looking at the function, I know sine of anything can be as big as negative, or as little as -1 and as big as 1. So I can make my y min and max, maybe I'll do -5 to 5. Then I'm going to hit graph to get a view of what's going on here. So this is what my function looks like. It's a velocity function, okay? It's really, really important to know when we're looking at this graph what type of graph we're looking at. Okay, so this is a v of t graph. So what I need to understand now is going back here, I need to find v of 4, and I need to find a of 4. I'm going to start with v of 4. Notice my function is v of t, right? Instead of cranking out by hand, typing this into your calculator, right, we can get v of 4, since the graph is v of t, we can get v of 4 just simply by tracing 4. So what I'm going to do is I'm going to go to my graph and trace 4. And this y value right here is my velocity. So what I know is that v of 4 is 2.9787165. And when I write that down, right, I can round that to 3 decimal places or truncate. Okay, everything is going to be 3 decimal places. So I'm going to call it 2.979. So v of 4, I know is 2.979. Again, I told you I'm not as concerned with the number as I am with its sign. What I know is that that number is greater than 0. Now I need to calculate a of 4. Okay, a of 4, we know we have to do the derivative, right? But we don't have to derive this function by hand. Even though I know you can, right? It's just a chain rule problem. Okay, but we don't have to do the derivative by hand because we can do it through our calculator, right? The calculator is really good at finding derivatives at a point. So look at what I'm going to do. I'm going to go back to my calculator, and I want to do the derivative of this graph at time 4. So at t equals 4, or in the case of my graph, at x equals 4. So I'm going to go hit second calc, and I can do that derivative right down here by hitting number 6. And it'll ask me where to do the derivative, and you just type in 4, and it'll say dy dx equals this number right here, negative 1.164. So that's how I can calculate very quickly and easily on my calculator graph here. I can calculate a derivative at a point very simply. I don't have to do the chain rule or anything like that. I'll let my calculator calculate that derivative. What you need to know is that you needed to do a derivative to go from velocity to acceleration. So my acceleration then, negative 1.164, which I know is a number that is less than 0. Okay. So what I can say now is v of 4 is positive, a of 4 is negative. I need to check both. Therefore, the signs are different. So I know that the particle is slowing down. And I'm going to justify this by saying because v of 4 and a of 4 are opposite signs. All right, so we can get any velocity at any time we want by tracing the velocity graph. We can get the acceleration by doing the derivative of the velocity graph at that point. And there we go with part A. Part B says, find all times t on the interval 0 is less than t is less than 3 when the particle changes directions. Justify your answer. Okay, so this was in the day 24 video talking about a particle changing directions. What we know is that an object changes directions, right, whenever velocity switches signs. So I want to look for velocity to be changing signs. What I need to know is that I'm looking at a graph of velocity. So let's go back down and take a look at our graph. The other thing I want you to pay attention to is we're only looking at a domain from 0 to 3, right? So when I go to my graph here, the first thing I want to do is adjust my window. Instead of being 0 to 6, it's going to be 0 to 3. And again, I'm looking for this velocity graph to change signs. Well, what I can see is at the beginning here, my velocity is positive. Remember, I'm just looking at whether or not this graph is positive or negative, meaning is it above or below the x-axis. I can see right here that in all this time right up here, I'm getting positive numbers for velocity. And it stays positive until right before 3 seconds, my velocity switches to negative. So again, I'm looking for velocity, the graph I have, to be changing signs. The only place where velocity changes signs is right here at this 0, okay? Now we don't have to do a sign test here because we can visually see that this line is this velocity is positive on the left side of the 0 and negative on the right side of the 0. So I'm looking for one number right here. So what I'm going to do is I'm going to go to my menu here, my second calc menu, and what I'm doing is I'm trying to find a 0. So I'm going to hit number 2. And to find the 0, I need to choose a number on the left side. I need to bound this thing on the left side and on the right side. All right? And as long as there's only one 0 in between. So I'm just going to arrow over a little bit here. And I'm going to hit enter. So I'm on the left side. Now I just have to arrow over so I'm on the right side. This takes a little while. Okay, now I've crossed. I can tell my y is negative, so I'm on the right side of the 0. I'm going to hit enter. It says guess and just hit enter again. And it comes out with 2.707. So that is the time. That is that exact time when my velocity switches from positive to negative. Therefore, the particle just changed directions. It went going to the right, and it switched to going to the left. So I'm going to go ahead and write that down. Notice there's no units here because they didn't give any units in the problem, okay? But that's the only time t where my particle changes directions. It's 2.707, and I need to justify that. My justification is because that's when v of t changes signs. So just a little introduction, again, on how we can use our calculator. We can use our calculator to find zeros. We can use it to trace values. We can use it to do derivatives at a point. We can use it to find maxes and minimums, if that's helpful. Okay. So I just wanted to give you one quick introduction to those types of problems. And that'll be it for today. I'll see you guys tomorrow. And we'll get some more practice on this. Keep studying those notes from especially day 24 and 23, as well as this one. See you guys later. 2 chains. Bye.